Right now, you're sitting on a rock that's spinning at 1,000 miles per hour, hurtling through space at 67,000 miles per hour around a star that's one of 100 billion stars in our galaxy. And our galaxy is just one of trillions in the observable universe. But here's the thing, that's not even close to how big the universe actually is. Today we're going on a journey to understand just how incomprehensibly massive our universe really is. And I promise you, by the end of this video, your perception of everything will be forever changed. But first, let's start with something we can actually wrap our heads around, our own planet Earth. Earth has a diameter of about 718 miles. If you could drive around the equator non-stop at highway speeds, it would take you about 17 days. That seems pretty big, right? Well, let's put that in perspective. You could fit 1.3 million Earths inside our Sun. The Sun is so large that its diameter is 109 times bigger than Earth's. But even our massive Sun is just a tiny dot in our solar system. The distance from Earth to the Sun, what we call 1 astronomical unit or AU, is about 93 million miles. Light, traveling at 186,000 miles per second, takes 8 minutes and 20 seconds to reach us from the Sun. But our solar system extends far beyond the Sun. Pluto, at its farthest point, is about 49 AU from the Sun. But the true edge of our solar system, the Oort cloud where comets originate, extends out to roughly 100,000 AU. That's nearly 2 light-years away. So our entire solar system is a bubble about 2 light-years across, floating in the vast emptiness of interstellar space. But this is where things start getting really mind-bending. The nearest star to our Sun is Proxima Centauri, located 4.24 light-years away. Now, a light-year is the distance light travels in 1 year, about 6 trillion miles. So Proxima Centauri is roughly 25 trillion miles away. To put this in perspective, if Earth were the size of a grain of sand, Proxima Centauri would be another grain of sand about 4 miles away. The fastest spacecraft ever built, NASA's Parker Solar Probe, reaches speeds of 430,000 mph. At that speed, it would still take over 6,000 years to reach our nearest stellar neighbor. Within 10 light-years of Earth, there are only about 30 star systems. Within 50 light-years, there are roughly 2,000 stars. These distances are so vast that astronomers had to invent new ways to measure them. But even these interstellar distances are nothing compared to the scale of our galaxy. Our Milky Way galaxy contains somewhere between 200 to 400 billion stars, though recent estimates suggest it could be even more. The galaxy is roughly 100,000 light-years across and about 1,000 light-years thick. We're located about 26,000 light-years from the galactic center on what's called the Orion Arm, basically in the cosmic suburbs. If our solar system were the size of a coin, the Milky Way would be about the size of the continental United States. Here's something that will blow your mind. Our entire solar system is moving around the galactic center at about 514,000 miles per hour. Even at that incredible speed, it takes us roughly 225 million years to complete one orbit around the galaxy. The last time Earth was in this same position, dinosaurs were just beginning to emerge. At the center of our galaxy lies Sagittarius A, a supermassive black hole with a mass 4 million times that of our Sun. This cosmic monster helps hold our entire galaxy together through its immense gravitational pull. But as massive as our galaxy seems, it's just one of countless others scattered throughout the universe. Our nearest major galactic neighbor is the Andromeda Galaxy, located about 2.5 million light-years away. Andromeda is actually heading toward us at about 250,000 miles per hour, and in roughly 4.5 billion years, our two galaxies will collide and merge into what astronomers playfully call Milky. The Milky Way and Andromeda, along with about 80 smaller galaxies, make up what's called the local group, a gravitationally bound collection of galaxies spanning about 10 million light-years across. But the local group is just a tiny part of an even larger structure called the Virgo supercluster, which contains over 1,100 galaxies and spans about 110 million light-years. And we're not even at the center. We're in the outskirts of this cosmic neighborhood. On even larger scales, superclusters are arranged in what astronomers call the cosmic web, vast filaments of dark matter and galaxies separated by enormous voids that can be hundreds of millions of light-years across. These voids are so empty that a typical void contains less than one galaxy per volume that would normally contain 2,000 galaxies. Now we come to the observable universe, the spherical region of the universe we can actually see. This might seem like it should include everything, but here's where physics gets really interesting. The universe is about 13.8 billion years old, so you might think we can see objects up to 13.8 billion light-years away. But because the universe itself is expanding, the most distant objects we can observe are actually about 46.5 billion light-years away. This gives our observable universe a diameter of about 93 billion light-years. Here's the mind-bending part. The light from the most distant galaxies we can see started its journey when the universe was only a few 100 million years old. We're literally looking back in time. The cosmic microwave background, the afterglow of the Big Bang, shows us what the universe looked like when it was only 380,000 years old and first became transparent to light. The Hubble Deep Field images reveal that there are roughly 2 trillion galaxies in the observable universe. Each galaxy contains hundreds of billions of stars. The total number of stars in the observable universe is estimated to be around 10^24. That's more stars than grains of sand on all the beaches on Earth. But here's the truly staggering part. This observable universe, as incomprehensibly vast as it is, might be just an infinitesimally small fraction of the actual universe. The universe beyond what we can observe could be vastly, perhaps infinitely larger than what we can see. According to cosmic inflation theory, in the first fraction of a second after the Big Bang, space itself expanded faster than the speed of light, stretching the universe to enormous proportions. Some models suggest that the entire universe could be at least 10^23 times larger than our observable universe. Others propose that it could be infinite in size. If the universe is infinite, then every possible arrangement of matter that could exist does exist, including exact copies of you, me, and Earth itself, scattered throughout the cosmos. MIT's Max Tegmark calculated that if the universe is infinite, there should be an exact copy of you about 10 to 29 meters away. That number is so large it's essentially meaningless to human comprehension. It's larger than the number of atoms in the observable universe raised to the power of the number of atoms in the observable universe. And the universe isn't just large, it's getting larger every second. Dark energy is causing space itself to expand at an accelerating rate. Galaxies beyond our local group are moving away from us, and this expansion means that much of the universe will eventually become unobservable to us as it gets carried beyond our cosmic horizon. Let's try to put this all in perspective with some mind-bending comparisons. If you could shrink the observable universe down so that Earth was the size of a single atom, the observable universe would still be about the size of a football field. The ratio of your size to the size of Earth is roughly the same as the ratio of Earth's size to the size of the Sun. But the ratio of the Sun's size to our galaxy is like comparing a blood cell to a city. If the entire history of the universe were compressed into a single year, human civilization would have existed for only the last few seconds before midnight on December 31st. Your entire lifetime would be less than the blink of an eye. And yet here you are, a conscious being made of star stuff, contemplating the very cosmos that created you. The atoms in your body were forged in the hearts of dying stars billions of years ago. So how big is the universe really? The honest answer is that we simply don't know. It could be infinite, it could be mind-bogglingly finite, or it could be something our human brains can't even conceptualize yet. What we do know is that we exist in a cosmos so vast and magnificent that it challenges our very ability to comprehend it. And somehow, against all odds, we're here to witness it. If this journey through cosmic scales has left you as amazed as I hope it has, make sure to subscribe for more mind-bending explorations of our universe. And let me know in the comments, what aspect of the universe's scale surprised you the most? Thanks for joining me on this cosmic journey. See you in the next video.